DDoS attacks. You've probably heard of them, right? They're one of the oldest tricks in the book when it comes to internet attacks. But believe it or not, they found a brand new and pretty dangerous playground in the world of Web 3. So today, we're going to break it all down. How these attacks are retooled for blockchains, what the fallout actually looks like, and most importantly, how the crypto world is fighting back.
Hey everyone, welcome to CodeAccessHub. Our whole goal here is to take really complex tech topics, just like this one, and make them super easy to understand. We want to give you clear, practical explainers. So, let's get right into it.
Okay, here's our game plan. First, we'll get a handle on what a classic DDoS attack is. We're calling it the digital traffic jam. Then, we'll see how that battlefield changes for blockchains. After that, we'll look at some real-world examples of when blockchains go dark. And of course, we'll dive into how we build digital fortresses to defend against this, and wrap up by talking about why this is a constant fight for resilience.
All right, first up, the digital traffic jam. Before we can talk about blockchains, we got to make sure we're all on the same page about what a DDoS attack actually is. It's a concept that's been around forever, but its core idea? It's brutally simple. So just think of a massive, gridlocked traffic jam on a highway. That's a DDoS attack in a nutshell. In the normal Web 2.0 world, an attacker uses what's called a botnet, which is basically an army of hacked computers, to just flood a single target, like your favorite website, with junk traffic. Now, the goal isn't to steal your password or data. Nope, the whole point is to overwhelm the server so that it just grinds to a halt and crashes, denying service to actual legitimate users like you and me.
But, and this is a really big but, this is where things get completely different for blockchains. See, in the old school web, the attacker has one single target to aim at, a central server. But a blockchain? It's decentralized by nature. There is no one server to take down. An attacker has to try and fight a whole distributed network of nodes all at once. And that, my friends, requires a totally different playbook.
So, the big question is, how do these attackers take this old trick and make it work in this new, decentralized world? Well, if you can't block the highway, you clog it with cars. They don't attack the network itself, they attack the transactions running on it. The most popular method by far is something called transaction flooding. It works in 3 simple steps. First, the attacker just spams the network with thousands upon thousands of tiny, worthless transactions. Second, all that junk starts to fill up the new blocks, and more importantly, it clogs up the mempool. You can think of the mempool as like a digital waiting room, where transactions hang out before they get confirmed. And third, with that waiting room totally packed with spam, your legitimate transaction, it gets pushed to the back of the line, gets delayed for hours, or maybe even dropped completely.
But the attacks can get way more clever and way more targeted. They can go after smart contracts directly. For example, they can launch gas limit attacks. Since every single operation on the network costs gas, kind of like fuel for your car, attackers can send transactions specifically designed to burn up all the available gas, which causes the smart contract to stall out. They can even deploy parasitic contracts that act like digital leeches, sucking up all the gas from other essential services. And then there are re-entrancy attacks. This is a really clever one that's like finding a bug in an ATM that lets you withdraw cash over and over before the system even realizes your account is empty.
And look, this isn't just some theoretical stuff we're talking about. These attacks are happening right now to some of the biggest projects in crypto, and the consequences are very, very real. 400,000. Just let that number sink in. That's how many spam transactions were hitting the Solana network per second back in September of 2021. The sheer volume is just mind-boggling.
And what was the result of that insane flood of transactions? It knocked the entire Solana network completely offline for 17 hours. That very same month, Arbitrum One, a huge Layer 2 network, got hit with a similar attack that took it down for 45 minutes. And it's not always just about causing chaos. Sometimes it's a straight-up shakedown. The website bitcoin.org was hit with a classic DDoS attack, and the attackers demanded a ransom payment to make it stop.
So what does this actually feel like for a regular person just trying to use the network? It means you're trying to make a trade, swap a token, or just move your assets from one wallet to another, and nothing happens. The screen just stares back at you. For all intents and purposes, the whole system just becomes frustratingly unusable. So how can you tell if the network is just having a busy day or if something more sinister is going on? Well, there are a few dead giveaways. The biggest one is a really sudden, really dramatic slowdown of the entire network. Or services you use just become totally unavailable.
You might also spot a massive, unexplained spike in transactions on a block explorer or just weird activity, like a huge surge of traffic in the middle of the night.
Okay, so that's the problem, and it is a big one. The crucial question is, how do we fight back? Well, the good news is that developers and operators have a whole arsenal of tools to defend their networks, and it's all about building layers of security.
At the core network level, a few strategies are absolutely key. Rate limiting is basically like a bouncer at a club, making sure no single person can just rush the door. Transaction filtering works just like the spam filter in your email. It identifies and throws out junk transactions before they can clog everything up. And of course, you've got the proactive stuff, like regularly auditing smart contracts and stress testing the network to find weak spots before the bad guys do.
And for the people who are actually running the infrastructure, the node operators, it really just comes down to good security hygiene. We're talking about the fundamentals, strong access controls, keeping every piece of software and hardware updated, constantly watching for suspicious traffic, and spreading nodes out all over the world to make the network tougher.
Okay, so we've covered the network and the operators, but what about you? Is there anything you can do? Absolutely. First and foremost, and I cannot say this enough, use a hardware wallet. This keeps your keys offline, which means your funds are safe even if the service you're using is getting hammered. Also, stay informed, check network status pages, and finally, vote with your feet. Support and use projects that are open and serious about their security.
But here's the thing we all have to understand. There is no silver bullet here. Defending against DDoS attacks isn't about building one perfect wall. It's a constant, evolving cat and mouse game. And this brings us to a really important question. If we know how these attacks work, and we have all these defense strategies, why are they still so hard to stop on a blockchain?
Well, it boils down to three core challenges. First, there's a strong financial motive, whether it's demanding a ransom or just trying to sabotage a competitor. Second, for smaller, up-and-coming networks, it can actually be pretty cheap for an attacker to launch a really effective attack. And finally, the very thing that makes blockchain so amazing, its decentralization, is also a double-edged sword. It's resilient, for sure, but it also makes it incredibly hard to block malicious traffic that's coming from thousands of different places all at once.
And let's be crystal clear. This isn't just a technical problem. DDoS attacks are a serious crime in most countries, and they can come with huge fines and even jail time. Blockchain projects have a real responsibility to follow cybersecurity regulations, and in some cases, they're legally required to tell users and authorities if an attack leads to something like a data breach.
Ultimately, what we're looking at here is a classic arms race. The future security and stability of this entire ecosystem really depends on the defenders constantly evolving and innovating, always trying to stay one step ahead of the attacker's creativity.
If you enjoyed breaking all of this down and you want to dive deeper into more topics just like this, you know where to find us. We have all of our explainers over on our YouTube channel, CodeAccessHub. Thanks so much for watching. If you found this useful, you know the drill. Go ahead and like, share, and definitely hit that subscribe button for more. This is CodeAccessHub. Access, learn.